So guys, we are looking at the simple pendulum. Yeah, so let's look at this example that I sent to the group, and then I'll send some more questions that you can attempt. So this question says the bob of the pendulum shown below takes 0.25 seconds to swing from A to C. So you have this simple pendulum here. If A and C are extreme points, determine, number one, the period of the pendulum. So from what we discussed, what is the formula for period? Remember, we said period is the time taken for a complete oscillation to be generated. Yeah, so I think I gave you two formulas that we can use to find the period of a pendulum. The first one, I said that period is equal to 1 over the frequency. This was the first formula that I gave you in determination of the period of a pendulum. Now when you look at this formula here, we cannot use this formula because there's no frequency here, right? We don't have frequency. So what do we have instead? We have the time it takes the bob to swing from A all the way up to C. All right, there's this other formula that I gave you where you say that period equals the time over the number of oscillations. Period equals the time over the number of oscillations. So the time given here is 0.25. The time it takes for the bob to swing from A to C is 0.25. So the time we have. How about the number of oscillations? So I told you to say from this point A all the way up to the point C, we have got 1 over 2 or 0.5 oscillations. Those values that I gave you are supposed to be mastered. So it's very important that you get to know that from A to B, you have 0.25 or 1 over 4 oscillations, right? Number of oscillations. If it swings from A to B, you are going to have 1 over 4 or 0.25. From B to C, you are still going to have 1 over 4 or 0.25. Meaning from A up to C, you say 1 over 4 plus 1 over 4, you get 1 over 2 or 0.5. So here, this is the formula that we're going to use to find the period of the pendulum. We're going to say that the period of the pendulum is equal to the time over the number of oscillations. So the period will be equal to, the time is 0.25 over the number of oscillations it takes from A to B. Number of oscillations from A to B are 0.5 or 1 over 2. When you say 1 divided by 2, you get 0.5. And so the period of this pendulum, when we do this on the calculator, we are having 0.5. Now remember, period is time, so it is supposed to be in seconds. So we are saying 0.5 seconds. That is the period of the pendulum. Question 2 is asking us to calculate the frequency of the pendulum. What is the formula for frequency? So what I told you was that there is an inverse relationship between period and frequency. If period equals 1 over frequency, then frequency equals 1 over period. All right? Frequency equals 1 over period. So the frequency will be equal to 1 over, now what is the period? The period is 0.5. So the frequency in this case, when you say 1 divided by 2 on the calculator, you are going to have 2. What are the units of frequency? Hertz, right? So 2 hertz, like that. This is the formula. This is the answer. If you don't use this formula, you can as well say frequency equals the number of oscillations over the time. Frequency will be equal to the number of oscillations from A to C. You've got 0.5 or 1 over 2, 1 over 5, 1 over 2 oscillations. So 1 over 2 or 0.5 oscillations. The time it takes is 0.25. Now if you say 1 over 2 divided by 0.25, you are still going to have 2 hertz as your frequency. So either way, the answer would still be correct.